Let us now look at our second example on electric forces and electric fields. In this example, we have three charges placed at the vertices of a right-angled triangle, as shown there. Now we have to determine the force experienced by the negative 6 microcoulomb charge placed at point B. So, number one, force experienced by the charge at B due to the charge at point A. That will be K, charge A and charge B over the square distance AB squared. Now, do we have AB? Okay, so we can get AB using Pythagoras theorem. In this case, we have the hypotenuse is 10, so that is 10 squared minus 6 squared. So AB, since this is a right-angled triangle, will give us 8 centimeters, which is 0.08 meters. Now we can compute for the force. So this will give us force at point B due to the charge at point A is 9 times 10 power 9 times the magnitude of the product Q1 and Q2, which is QA and QB. So QA is 4 microcoulomb. That is 4 microcoulomb. That is, a micro is a 10 to the power negative 6. So we have that times charge at B is negative 6 times 10 power negative 6 over the square distance, which is 0.08 squared. So force BA is, let us compute that first. So we have 9 exponent 9 multiplied by 4 exponent negative 6 multiplied by negative 6 exponent negative 6 divided by 0.082 squared. What do we have? We have the 3 point. We have that 3.7 newtons, 7.5, sorry, that is 7.5 newtons. Now, where is the direction of this force? Okay, I've not included the negative here. I've just taken the magnitude, but we will have to consider it. So, since this is a negative charge and this is a positive charge, B is attracted to A. Charge B is attracted to charge A. So the force is toward A. So this force is toward A. Now let us compute the force FB due to charge C. This will give us K QC QB over the square distance RBC squared. RBC squared. Let us substitute. So we have 9 exponent 9 times the magnitude of QC and QB. Now QC is 2 times 10 power negative 6. Again, remember 2 microcoulomb implies 2 times 10 power negative 6. Then QB is negative 6 times 10 power negative 6. Then we take the magnitude over the square distance. So that is 6 centimeters. If we convert it to meters, that will give us 0.06 squared. Okay. Use the calculator again. We have BC equal to, this will give us 30 newtons. Now again, since this charge here is negative, it will be attracted to a positive charge, which is at point C. So this force is towards C. Now let's see what we have. If this here is our x or y plane, then we have a charge at this point, at point B. So if this is B, then we have a force to the right and a force upwards. So this is FBC, it is directed upwards. Then FBA is directed to the right. So if we want to compute the magnitude of these two forces, we know that it will be in that direction. It will be in that direction, and that there will be the angle. So let us compute for F. Okay, again using Pythagoras theorem. Now this is simple. Since we have the x and y component of F, this will be F is the square root of FBA squared plus FBC squared. So what will be F? What will be F? So let us compute, please. So we have 3.75 squared plus 30 squared. Taking the square root of that, we have 45.16. We have 45.16 newtons. So that will be the magnitude of the force. Then the angle, the direction, will be theta is equal to tan inverse of the y component of this force, which is FBC over FBA. So this will be the tan inverse. This will be the tan inverse of, now FBC is 30 over FBA is 33.75. So what will be the angle? What will be the angle? So we have 30 divided by 3.75. Then shift tan inverse of that, we're getting 41.63. 41.63 degrees. Okay, so we can leave the angle like that. That implies we've measured the angle from the positive x-axis going in the anti-clockwise direction. So that's our direction. Now let us look at the second question. Now calculating the electric field at point B due to the charge at point C and the charge at point A. Okay, in this case we will have to avoid the use of the forces calculated using Coulomb's law so that we can prove the answer in part A. So for electric field we'll have to use this formula. So this time we'll have to use, so this is part B, have to use E is equals to KQ over R squared. So now let us find electric field at B due to charge placed at C. So this will give us electric field at B is equal to K times the magnitude of charge C over R squared. So that will be K is 9 times 10 power 9 times the magnitude of charge C, the magnitude of charge C so charge C is 2 microcoulombs. Charge C is 2 microcoulombs. So we'll have to, is 2 times 10 power negative 6 there over this, the distance is 0.06. The distance is 0.06 squared. So what will be the magnitude of the force there? Let us compute first. So we have 2 exponent negative 6 times 9 exponent 9 divided by 0.06 squared. So we have 5 million, or 5 times 10 power 6 newtons per coulomb. Similarly, let us compute the electric field at B due to charge placed at point A. So this will be E is equals to K, then the magnitude of QA over the distance, which is AB. So this is 9, that is 9 times 10 power 9 times the magnitude there of charge A, which is charge A is 4 microcoulombs. So that is 10 power negative 6 over this distance AB we've calculated already, and we have 0.8 squared. Let us use our calculator to compute that. So we have 9 exponent of 9 exponent 9 multiplied by 4 exponent negative 6 divided by 0.08 squared. So we have 5 562 562 5000 newtons per coulomb. Now electric field is a vector, and by superposition principle we have to add these two fields that we have to add them to find the magnitude. But how are we going to add them? So this field here is along, this is along the x-axis. This one is along the x-axis. So we have one field in y-axis and another field in the x-axis. So we have to use Pythagoras theorem to find the magnitude. So this will be, therefore, you can say, therefore E is equal to the square root of the field at B, which is in x-axis, and the field at B, which is in y-axis. So this will give us, in x-axis we have, so we have to square this by Pythagoras theorem. So we have 36,250,000 squared plus 5 million, that is 500,000 squared. Then we take the root. This will give us field at B equal to, let us compute that. So of that squared plus okay. So when we compute this, we are getting 7,526.612 newtons per coulomb as the electric field at point B. This is the total electric field at point B. Now in part C, we've been told to prove the magnitude of the force that we have in A using this electric field. And you've seen that we've used different methods here. So if we are doing the correct thing, then we should get the same amount of force. Okay, now we know that force is related to electric field by F is equals to the charge multiplied by the field. So now we are talking about charge placed at point B and the field at point B. So the charge placed at point B, if we look at the diagram again, we'll see that this charge is the -6, the -6 microcoulomb, which is -6 times 10 power -6 coulombs. Then the field that we have is 7,525,996.612. So let's see what this will give us. Please try to compute. So this will give us 45.16 newtons. Okay, so this is negative, and of course this is true because the fields that we have, since this is a negative charge which is placed at point B, so at point B there is that charge, and we know that field is directed towards the negative charge. Field is directed toward the negative charge. Okay, and that is the reason why we are getting a negative force here. Now we are not interested in this negative here, we are interested in the magnitude. We've been told to prove the magnitude, so we know that to get the magnitude of F, we just remove the negative sign there, so the magnitude, so the negative there is just showing the direction of the field on this charge. Okay, so that is 45.16. then the force in magnitude will be exactly 45.16 newtons. Hence proved. Thank you for watching. Please subscribe to my channel if you like learning with me. Also invite others to subscribe to my channel. Also leave me a comment. Okay, if you have a question, please leave me a comment and like the video. See you next time. Thank you.